Okay, so now let's look at the line of best fit. Sorry. So the line of best fit is basically a line that we usually draw for a scatter plot that can allow us to sort of determine to sort of like model the relationship. So what a line of best fit, or what we call in year 12, the least squares regression line, is basically a line which basically is sort of like the average of all of the points, essentially. And this line we can determine using our calculator. Again, I will be showing you how to do that on your calculator, although it's not necessarily required for Unit 2. So the line of best fit just allows us to make reliable predictions. So what that means is we draw this line based on the data, and let's just say we were wanting to determine what the value will be approximately based on this trend. Let's just say we have something that has a, let's just say we have something that has a length of 12 millimeters, okay? So that's like somewhere over here. And basically from this line, what we can do is we can find where 12 is and then work out what it corresponds to in terms of width. So it will allow us to predict the y value or the response variable based on a random explanatory variable, just based on the trend that is given to us. So the data has a trend, and when we use our data to analyze this and construct this line of best fit, we can then use the line of best fit to make reliable predictions. Okay, so how do we determine the line of best fit? Now in Unit 1, you will have covered this specific equation. So I'll just quickly recap this to you in terms of data analysis. So y equals a plus bx. So that is the equation that we use. Now y is your response variable and x is your explanatory variable. So whatever is given to you in the question, you just write that in. So for example, in the previous question where the response variable is width, you will just write width for y, and for x, you just write the length. Now a and b are the variables that we need to determine, and we can determine them on our calculator. So a corresponds to the y-intercept. So in terms of the graph, what is the y-intercept? So we can't really see the y-intercept here because the graph starts at 7, but basically the y-intercept is the point on the graph. So I'll just sketch it here. So let's say this is your line of best fit. And let's say this is 0, this is 0. Okay? And this is the EV, and this is your RV. So what that line of best fit essentially, or what that y-intercept essentially is, it is the point at which the line of best fit touches the y-axis. So whatever this point is, that is your y-intercept. So when the x value or the explanatory variable is 0, at what point is the line of best fit touching the vertical axis? So that is your y-intercept of your line of best fit. Now what about the slope? So the slope is a measure of the steepness of the graph. So just to tell you how much is the y values increasing or decreasing for every 1 unit increase in the x value. So for example, if we move 1 unit across, how much is it increasing by? So this is your slope, essentially. Okay? So if my x value increased by 1, how much is my y value increasing or decreasing? Okay, so now how do we actually determine this line of best fit? So what we do is we input this given data onto your calculator. So like I said, you'll usually be given a data table like this. And all you do is you pop that into your calculator. Go back, okay. So once you pop that onto your calculator, you do a linear regression analysis. Now again, I won't be going through a specific calculator technique. However, if you do need help with that, let me know in the chat. So once you do a linear regression analysis, your calculator will basically tell you what the A value is and what the B value is based on that data. So once you've determined that A and B value, another thing your calculator will also tell you is the R value. So remember from the previous question, not the previous question, the previous slide, we looked at what the R value means. So your calculator will also spit this out and it will tell you what that R value is when you do a linear regression analysis. So very useful, it will tell you the A value, the B value, and the R value. And then basically once you've determined the A and B value, sub that into this general equation template. And you replace Y and X with the actual response variable and the explanatory variable. So now let's actually look at an example. So determine the least squares regression line when the lifespan years is predicted from the sleeping time of a species. Round your answer correct to 3 significant figures. So here I've actually shown you a calculator example using the Casio ClassPad. Now if you want to know how to do it on your TI Nspire, let me know as well in the chat and I'll be happy to help you. So first step, we've got our data. First step is to determine what our explanatory variable is and what our response variable is. Now in this question, they haven't given us a graph. So how do we actually tell? Well, it's pretty obvious from the question. So it's saying, determine the least squares regression line when the lifespan is predicted from the sleeping time. So the key word is predicted from. So we're predicting lifespan from the sleeping time. So that means if the sleeping time changes, the lifespan will change. So therefore this is your EV and this is your RV. Okay? So once you've determined that, we plop our answer, we pop our data into the calculator. So I'm going to pop this this column and this column onto my calculator. So in list 1, I always like to put in my explanatory variable. So although it's the second row in the data table that they've given us, I put it into the first column. And the reason for that is and I'll show you why that's the reason in the next section. So I've put my sleeping time in the first column, my list 1, and my lifespan in my list 2. Now, if you want to be super duper not mess it up, if you don't want to mess it up and you want to be super duper confident, label the list. So literally write lifespan and sleeping time before you enter the data so you don't get confused. So then what you do is you go into calc and then you should see something called, actually let me just get my calculator up so I'm not confusing you guys. Yep, so you go calc and then you should see regression. So calc regression and then linear reg because we're doing a linear regression. So once you click on linear reg, you should get something like this. And all you do is in the X list, you just write in the list that corresponds to the explanatory variable. So I just put in list 1 because that's what I've labeled it as, or what I've put the data as. And then Y list is a response variable list. So I've put list 2. And the rest, just leave it as it is and just press OK. And then your calculator will open up a screen like this. Just one thing to make sure is over here, you want it to be Y equals A plus BX. Sometimes it will be written as Y plus AX plus B. Just make sure it's not like that because otherwise you will mess it up. Make sure it is Y equals A plus BX. So you can just click on the toggle menu and change it. Okay, so then you've got your A value, you've got your B value, your R value as well if you ever need it. All you do now is just write the equation. So lifespan, my response variable, is equal to 38.9, so remember rounding to 3 significant figures, minus 2.36 times by sleeping time. So as you can see, I've taken the A and the B value from what my calculator gave me and just fitted it into the equation, the general equation, and replaced the Y and the X with the actual response variable and explanatory variable.